Okay, so we're starting a new unit, and for many of you, you might like this unit because there's not a lot of heavy duty mathematics involved as far as arithmetic goes. So many students find it much easier. It's just making sure that they're using the language required in order to demonstrate that they understand how relationships work. So our prerequisite skill today is I will be able to distinguish from a graph the type of relation. So this is reviewing actually different types of relationships that you've seen thus far in your high school career. So first of all, in math, we're concerned about the type of relationship between variables. Just as there's relationships between people, there are relationships between variables. So what we need to do is when we know the type of graph, then we're able to answer questions which are then useful in making decisions related to the relationship between those two variables. Okay, so the purpose is for us to determine the type of relationship so that we can use that to predict, in some cases, future events. So the first graph that we're going to look at is something you've seen for a long time. So there are three types. And obviously, when you look at this one here, we have, oops, sorry, it moved on me. We have a straight line. Now, you know that the relationship, if you have a straight line, is actually a linear relationship. Now, when we're talking about linear relationships, we're talking about numerous things. One thing that's most common is slope, and you know that slope is rise over run. Okay, so you did that maybe in grade 8, but definitely in grade 9, 10, 11, and now we're looking at it again. Now, the only thing when we're talking about sloping rise over run, when you were in especially in grade 9, you would take and you would find a couple points and you would count the squares, the rise squares and the run squares. And that in some cases is fine, but one word of caution, and that is check the scaling on the axis. Just don't count squares. Now, in this case, it's fairly easy because we can see that when we count the squares, each square is worth 1. So we're fine if we just want to count squares for this example. But make sure you check that. So let's look at this example. We're actually going to calculate. And if we look at this, and I already have my triangle made, and I've looked at my scaling. So rise over run. So in this case, I'm going up 2. And the two that I'm going up is some kind of thing called megajoules. So that sounds like a scientific name to me. And that megajoules, if I look at its run now, as soon as I get this working, the run here is 1 and it's 1 hour. And when I do that, I'm not going to leave something as 2 over 1. It's just going to be 2. So my slope is 2. And after I've done that, then I want to know, well, what does that mean? What does it mean the slope is 2 in this example? Well, in this particular example, it means the following. It means that it takes 2 megajoules of energy for each hour of canoeing. So this is the hours of canoeing because I've checked my top of my graph. And you can see from our slope, it's megajoules per 1 hour. Okay, so the next type of graph that we're going to look at is again a graph that you've seen before. And in this case, it is the parabola. Yeah, the parabola you did a little bit in grade 10 and some more in grade 11. But a parabola is this type of shape. And when we're talking about a parabola, we're talking about a quadratic relationship. And a few of the things that are important when we're talking about a quadratic relationship is a thing called its vertex. So in this case, it's the highest point. So it's a place where the graph changes directions. So if I was reading this graph, and I'm just going to cover this for a second, if I was reading it, notice I'm watching the graph. As I'm pulling this back as if I was reading a book, does the graph go up or down? Well, it is going up, it's going up, it's going up until I reach this vertex point, and now it's going down. So the vertex in this case is the highest point. If my parabola opened down, my vertex would be the lowest point of the graph. So when we're looking at the vertex, we're interested in, first of all, if it opens down, such as this one, it has a maximum value. If it opens up, it has a minimum value. Now, if I look at this exact kind of graph, and it's kind of hard to see the actual wording. This one here says profit P, and the top number is 12,000. And along the bottom here, it says selling price. So in this case, I'm going to have a maximum profit. So the highest point is the maximum. And it happens when the selling price, I'm saying, is approximately 35. So if I actually dropped down from that straight down, you can see that it's approximately 35. It's between 30 and 40. Okay, now the maximum profit is $12,000, and it happens when the selling price, sorry, is 35. Okay, one more graph to look at, and that is our exponential curve. And I'm just going to close that there for a second. So when we're talking about an exponential curve, there's two different. There's called an exponential growth or an exponential decay. Now, the little bit of problems with these graphs is because they look almost like half of a parabola, especially if they only show you part of the graph. Okay, so if I look at my exponential growth one, it's very hard to see. Now, if the graph had gone further into negative y zones, or negative x zones, I should say, I would see that it wasn't a parabola. If you look at the exponential decay, it looks, I'm going up and I'm going down, but unlike a parabola that goes back up again, this one starts to creep along the x-axis. Now, with these types of graphs, and I'm just going to switch my paper here for a second, because although I'm doing it online, there we go. With these types of graphs, what we're looking at is a few different features. It doesn't have a vertex. It doesn't have a slope. So what does it have? First of all, when we're looking at these, and I've blown actually the decay one up, is I'm interested in the starting amount. Now the starting amount is related to the vertical intercept, and that happens in this case because it's decay at the top. Okay, so I'm interested in that because that tells me the starting amount of the item. If I look at this example and read it, this is percentage of original isotope remaining. So percentage of. So I'm at 100%. So that's what it means. There is 100% of the isotope at the start. Now, we're interested in the starting amount, but we're also interested in growth or decay factor, and that is a ratio. Now, because this is a decay, or even if it was a growth, the decay or growth factor is always, in this case, the percentage of half-life and then the percentage after 0 half-lives. So if I look here, and I'm just going to bring this up again, I'm starting at 100, so that's what I would put here. And I reach 1 is usually the best one. And you're saying, what on earth is she doing? I want to see how much this graph has gone down between 100 and 1. Now, I can't create a triangle like we did with the linear, so I couldn't do this. And the reason I can't do that is because it's not a constant decline. It's declining a different way. It's declining exponentially. So when I'm looking at this, I'm looking that it's going down after 1 half-life, between 0 and 1 half-lives, it's going down 50. So if I was looking at the decay factor for this example, it would be 50%. So my decay factor here would be 50. So if I was going to create an equation, that would be important for me. Last year, you made quite a few equations related to the financial mathematics, especially. Now, one important thing to remember is that it's much easier to read, in other words, calculate at the beginning of the graph. Okay, the reason being, if you notice at the beginning, you can see the numbers much better. What happens, however, when you get closer to when it starts creeping along this x-axis, it's very difficult to figure out how much it's gone down between, for instance, 7 and 8. On the graph, you're saying 0. It's not quite 0. It's approaching 0, but it's not quite that. So it's much easier to do that. Okay, so what you're doing now is you're going to practice a little bit. It shouldn't take you very long today. Okay, have fun.